Hello everyone, I am Shashidhar. Today I am with you to explain finite differences. Consider a function y is equal to f of x, which is a discrete valued function. Now let x0, x1, x2, etc. xn be the points where x1 equal to x0 plus h and x2 equal to x1 plus h, etc. xn equal to xn minus 1 plus h. That means all x values are equally placed. The difference between adjacent x values are same. Now let the corresponding values of y that be y0, which is equal to f of x0, y1 which is equal to f of x1, y2 is equal to f of x2, etc. yn is equal to f of xn. That means corresponding to x values x0, x1, x2, etc. xn, we have y values y0, y1, y2, etc. yn. Now these x values we call it as argument and the y values we call it as entry. Now we will discuss what is finite difference. In this finite difference we divide it into two kinds. One is forward difference and another one is backward difference. Let me explain the concept of forward difference with the help of table. So consider x values like x0, x1, x2, x3, x4, xy and the corresponding y values y0, y1, y2, y3, y4, y5. So we restrict x and y entries up to x5 and y5. So that's enough to explain this concept. Actually we can go for up to yn, xn, yn also, but we restrict our explanation up to x5 and y5. Now the functional values, that is actually y equal to f of x. So y0, y1, y2, y3, y4, y5 are called functional values. So in the third column we draw the difference, that is y1 minus y0, we denote it as delta y0. So here in this picture it is written in the middle of y1 and y0. In third column, almost in the middle to y1 and y0, it is written delta y0. That shows it is the difference between y1 and y0. Next, y2 minus y1 we write it as delta y1. y3 minus y2 we denote delta y2. y4 minus y3 we denote delta y3. y5 minus y4 delta y4. These differences we call it as first forward difference and we denote in general as delta y. That is what written at the top of third column. Next, again find the difference of these first differences, that is delta y1 minus delta y0, we denote it as delta square y0. It is written in the fourth column. Delta y2 minus delta y1 we denote delta square y1. Delta y3 minus delta y2 we denote delta square y2. Delta y4 minus delta y3 we denote delta square y3. Now continuing, delta cube y, that means difference of second forward differences, that is delta square y1 minus delta square y0, we write it as delta cube y0. Delta square y2 minus delta square y1 we write it as delta cube y1. Delta square y3 minus delta square y2 we denote it as delta 3 or delta cube y2. Next, delta 4y, delta power 4y or delta 4y, that is delta cube y1 minus delta cube y0 we denote it as delta 4y0. Delta cube y2 minus delta cube y1 we denote it as delta 4y1. Finally, delta 4y1 minus delta 4y0 we denote it as delta 5y0. here since we have taken values of x from x0 to xy and corresponding values of y, y0 to y5, we get fifth forward difference only. If you take more x and y entries, we will get the more forward differences. So this table we call it as forward difference